Now, these structures we've been drawing throughout the notes, we've been calling them Lewis structures for covalent molecules. A covalent compound essentially is called a molecule when you're actually talking about the physical structure. Now, there's a process for doing this that we can go through each time in order to arrive at the final structure that represents what the molecule, looks like. The first step in this process is to determine your central atom. This is really simple because it's usually the atom that there's the least of. So if you've got a chemical formula, which I'd have to give you in order to draw the compound, figure out which one there's least of, put that in the center. Afterwards, draw the surrounding atoms around, let's go back. There we go. Space evenly around the central atom. And this is just a layout thing. In steps 1 and 2, you're just getting your layout in order to work well with your drawing and your electrons. After you do your layout, the next step is to determine the total amount of valence electrons. Now, it's important. You have to include extra electrons if there is a charge. And we'll see what that looks like when we do an example. The next step that you have to do is you have to place single bonds between the central atom and the surrounding atoms. So you're just going to draw on those straight lines that we talked about. After you draw on your straight lines, remember, each bond represents 2 electrons. So you have to subtract that from your total amount of electrons. Then, with the remaining number of electrons that you have, you're going to add them to your surrounding atoms until each surrounding atom has 8 electrons, or in other words, fulfilling the octet rule. Remember, each surrounding atom needs to have 8. The only exception, it's very important, would be hydrogen. Hydrogen only needs 2. After you get rid of the remaining electrons on your surrounding atoms, if you have any left over, you're going to put them as lone pairs on the central atom. Now, if when doing that, that doesn't fulfill the octet rule, you have to complete the octet rule with double or triple bonds. So let's work through an example real quick to see how this works. So we have the example of sulfur dioxide, SO2. This is commonly found in detergents and preservatives. Our first step is to create our layout of our compound. So S has to be our central atom because there's less of them. So S is going in the center, O is going on the outside. Our next step is determine the total number of valence electrons. Well, we've got one S. S is in, let's see what column it's in. It's in the, over here. So it's that 1, 2, 3, 4, 5, 6th column. So if it's in the 6th column, that means it has 6 electrons. Now, oxygen is also in the 6th column, but there's 3 of them. So we have 6 electrons times the 3 oxygens. We've got 18 from oxygen. So 6 plus 18, our total number of electrons is 24. The next thing we want to do is we want to add in single bonds. So let's draw in these straight lines between our central atom and our surrounding atoms. So we got a line right there, we got a line right there, and a line right there. Now, our total is 24, but we just put in 3 bonds. Remember, each bond is 2 electrons. If it's 2 electrons, that means we just put on 1, 2, 3, 4, 5, 6 electrons. Let's take that away from our pool. 24 minus 6, we've got 18 left. Now we've got to put electrons on the surrounding atoms until each has 8. Well, let's take a look at our surrounding atoms, which are oxygen. Oxygen has 2 electrons because of the bond. Needs 8. So we got to add 6 electrons. There we go. Big electrons. 1, 2, 3, 4, 5, 6. Excuse me. 7, 8 because of the bond. So let's do that again to the other option. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now let's think about how many electrons we just used up. If we count just the dots, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We just placed 18 electrons on our model. So we started with 18. Take away 18, we've got no electrons left. At this step, you always have to check your central atom. Your surrounding atoms should have 8 each. Your central atom only has, though, 1, 2, 3, 4, 5, 6. So in this case, this is when we have to add double or triple bonds. So what we're going to do is, in order to add the double or triple bond, we're going to take, let me grab a circle tool real quick. We're going to take one of these lone pairs. Let's do this one down here. Let me just highlight it. One of these lone pairs is going to actually come up and form a bond for a double bond. Remember, we call that type of bond when a lone pair joins a coordinate covalent bond. So if that lone pair comes up, what's going to happen is, let's see if we can get rid of it. We're going to have one single bond that forms instead. So let's look at what we have around sulfur now. We've got 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, so sulfur's good. This oxygen, let's double check. 1, 2, 3, 4 from the double bond. 5, 6, 7, 8 from the lone pair. So this oxygen still has 8. So our final structure is SO2. Take some time now to try the next example on your own, the carbonate ion. I'll leave that example on one of the whiteboards for you guys to check. Now, in terms of homework, here's what I want you guys to do. You'll be given this packet. This packet has 4 things on it. It has the structure, which we just talked about, the shape, which we're going to talk about on Friday, hybridization, and polarity. Throughout this unit, we're going to keep adding on these pieces of information so you can create this chart. Right now, we can only do the first column. So here are the ones that I want you to do for the first column. I want you to do, let's highlight these. These first 8 for homework, that should be all of them on the front page except for PCl5. Then I want you to do H2S, CCl4, SO2, and HCN. Now, HCN, one comment, make carbon the central atom and then the hydrogen and the nitrogen around it. After that, I want you to do O2, SO3, SO, and then NH4 and SO4 minus 2. Do those for homework. Again, you're just doing, though, the first column. You guys have the rest of the time in order to complete that, as well as we'll be passing back the test corrections today. And the test is out of 50 points. When you're done with your test corrections, please staple them to your test. And we'll see you guys on Friday.